color code card looks like this. This is one example, and Mrs. Haskell will be holding up some vocabulary words or keywords that I say if it helps you understand better by actually seeing the words written down. So I'd like you to all look at your color code card. This has what we call a pH scale on it. You notice it has colors, different color strips, and it has numbers. Now, I mentioned before that substances can be grouped as either acids, bases, or neutral substances. Neutral is kind of in the middle. It's really not an acid. It's really not a base. In fact, the atoms that make something an acid and the atoms that make something a base, neutral substances have equal amounts of both of those. So it's kind of like they balance each other out or cancel each other out. So we kind of think as neutral as being somewhere in the middle. So what number on your chart do you think that would be? What number is kind of in the middle?
7.
7. 7, if one of these substances that we test comes out the color that matches with the number 7, then we know that's a neutral substance. If the test strip, which you'll have in a few minutes, comes out a color that matches with a number less than 7, then we have an acid. So if it's more yellow, red, those sort of colors, we know it's an acid. What color do you think the paper might show if the substance is a base?
If anything less than 7 is an acid, what numbers are going to be a base?
11.
So the 11s, the higher numbers. So what colors are the higher numbers? Purples,
And greens.
darker greens, purples, blacks, blues.
Very good. Now, why should we care about any of this? And if we're not a chemist, why should we care about any of this? Well, you might have heard of acid rain. Okay. Our water on our earth and in the atmosphere around the earth is gradually getting a little more acidic, mainly because of pollution. We don't have a lot of factories here that have smokestacks that spit yucky looking smoke in the air, but in other parts of the country, there are a lot of those, and that pollution actually comes clear here. You know, that moves with the jet stream, with the prevailing winds, and can even get here, and it can damage. So it comes down when it gets with the water in the atmosphere up in the sky. It comes down. The rain that comes down is a little bit acid, and that can affect metal structures. That can affect bricks. That can affect cement. And also it can affect the ocean. And why it's a problem in the ocean is that one of the things acid reacts with are shells of ocean creatures, like clam shells, lobster shells, other ocean creatures that have shells. It actually breaks down their shells so their shells aren't as strong, and that's what's protecting them. So we actually have, our newest scientists at DEI has actually set up an ocean, a little laboratory with all kinds of fancy science-looking equipment to study ocean acidification and the effects that it has on the shells of our sea creatures, which of course is very important to us living here. All right, so let's get to our test. You will need your data table and something to write with. All good scientists set up a data table ahead of time. In big laboratories like DEI, we have scientists that work there all the time that are hired by DEI and paid by DEI, but also in laboratories like that, other scientists who might want to come, let's say, use our ocean acidification lab for a little while, they would pay to come there and use our lab. So as much of their work as they could do ahead of time, they would, because it would cost them money to rent the lab space. So scientists, you always get your data table ready ahead of time if possible, which we have done for you this time. So you'll see we have 4 columns. First column is the substance. That's the liquid that we're going to test. Then we have the pH color, which you will write down after you do your first test. Then we have the pH number. You'll write down the number that goes with that color on your little color code. And then you're going to write in that last column if that, based on that color and number, is that substance an acid, a base, or is it neutral? So what I'm going to have you do first is fill in the names of the substances that we're going to test. So in the first column, under the word substance, the first thing we're going to test is water. So you'll write water. And if you're not sure how to spell it, Mrs. Haskell is showing you. You're going to write water in that first blank. Underneath water, in the next box, the next substance is going to be vinegar. So we're going to write glass cleaner in the next box. Some of you might have Windex at home. That would be an example of a glass cleaner. Now, Mrs. Crowley, are they each going to have a little water sample, or are you going to take the water sample around for them to dip their pH strips in?
I'm going to take it around.
Okay, so now Mrs. Crowley's going to give each of you a pH strip. Now, in just a few minutes, this is a little piece of paper that actually is treated with a chemical. It's nothing that will hurt you. And when you test these liquids, you're going to hold the paper on the little piece of paper on one end, like you see Hannah doing. And when Mrs. Crowley brings the water sample around, you're going to dip the opposite end, the end you're not going to let go of it. You're just going to dip it in the cup, take it out, and immediately put it next to your color code and match up the color.
I'm giving you each 3, so make sure you have 3. Okay, so you're only going to use one at a time, though. One for each thing.
Yeah,
okay?
And be sure once you get one of them wet, don't let it touch the other ones. Don't even let it touch your data paper.
So put 2 of them up by your name tag.
When we dip it in, do we like put it right here?
You're going to put it right beside. Can Hannah show us again what you want us to do? Can Hannah, everyone watch what Hannah's doing, so you'll see what she's doing.
Yep, so I'm gonna take my pH paper and then I have my water sample in this little paper cup. So I'm going to dip just one end of it. You don't need to get the entire paper wet, just one end of it. And then as quickly as you can, you're going to match it up to your card.
Match it up with the
color of the original paper, and this is the color that it turned to. So I'm going to hold it up like so, right next to my pH card. And I think it looks like a 7. It might not be exactly the same color as on the card, but just try to get it as close as you can, the closest one possible.
Yes, and it's okay if you think it's this number and the person sitting beside you thinks it's the next number. It's okay. So Mrs. Crowley's going to come around with the water. You're going to dip your paper in, match it up with your color card, and then fill in the first row on your data table where it says water. You're going to write down the color, the number, and whether it's an acid, a base, or a neutral.
So what I want you to, when you're finished matching it up, put it into the other corner. So that can be the used corner, okay? And you're gonna need your safety glasses for the window cleaner. Okay, you ready? So hold one hand. Right next to your thing, find your thing. See where it matches up.
And it's important to make your observations as quickly as possible, because if you wait too long, sometimes the color of your pH strip changes a little bit, so that might alter your results. So try as best as you can to match it up right after your sample is put on it.
Do you put yellow?
So you're gonna, what color does it match
I
up
think
with?
yellow.
You want to say it's like what? Like a yellowish green or something?
I just did darker yellow.
So just write it there. Give it a color and a number of what you think it is and put it up on the left corner. Okay, it looks like everyone has written in
So what do we have for pH numbers?
7.
7. What else?
7.
7. Did anyone think a different one?
8.
Coben thought it was 8.
Okay, so
Alright.
they're all
7.
all at least pretty close to the middle, right? So if the number is in the middle, if the pH is in the middle of the scale, is water an acid or a base, or is it neutral?
Kinley.
Neutral.
Neutral.
It's
Right.
neutral. So in that last box on the top row of your data table, you're going to write neutral. All right, so now we're going to do the same process with vinegar. You need to use a new dry pH strip. These cannot be used over again. So you're going to do the same thing. You're going to dip it in the vinegar when Mrs. Crowley brings it to you. You're going to take it out and as quickly as you can, match it up with your color code and write the color and number on your data table.
Okay, match it up. Woo. Okay, you got a new one?
A little more exciting, maybe.
You did a 4? You did a 4 as well? I thought it was more 5. You said 5. Okay, everyone's done with this one.
Okay, what do we have for numbers?
4.
Michael had a 4.
Okay, 4.
9.
A 9? It didn't turn dark.
4.
4.
I was 6.
6.
5.
5. Okay.
Put it in the sun, you can see what it looks like.
So about 4 and 5.
Okay, so if we've got 4s and 5s, I'm not sure what happened with that 9. I think I'd put a question mark beside that. Sometimes we can figure those things out. Sometimes we can't. 4 to 6. So it's less than 7. Do you remember if that makes it an acid or a base or a neutral?
An acid.
It makes it an acid. So you will write acid. I sometimes get mixed up if the lower numbers are acids or bases. One way that helps me remember, A for acid comes before B for base. So the small numbers come before the bigger numbers. Now that's not why the numbers are like they are. That's just kind of a little way that might help you remember if you forget. Now, based on what we've found out so far, would somebody like to make a hypothesis or a guess how the glass cleaner is going to come out? If I've showed you a neutral and I've showed you an acid, what do you think this one's going to be?
13, he says. Probably up to the higher numbers, right?
We haven't had any higher numbers yet, have we? So if it is a higher number, does that mean it's going to be an acid, a base, or a neutral substance?
What do you guys think?
Base.
Base.
All right. Now, Mrs. Crowley, are you going to have them put their goggles on and dip?
They have their goggles on.
Okay, so you're going to have them dip just like they did with the water and vinegar?
Yep.
Okay, with that third clean piece of paper, and even though you might not use goggles, if you were using glass cleaner at your house to clean your windows, in a science lab, we practice these safe science practices all the time. At school and at DEI, we have to be more careful than you might be allowed to be at home.
Holy cow.
I don't know what to write.
Well, match it up and see what you think.
I did, but it's already blue now.
Ooh, Michael said it turned black. Ooh, it does look black, doesn't it?
You can see probably a little better with this one why you need to do your matching up right away. Because glass cleaner, you notice how you can probably smell it, even though you only had a little bit. That's because some of the molecules that it's made of have actually gone into the air and into your nose. That's how we smell anything we can smell. That's what has happened. Molecules from that, whatever it is, have gone into the air and then into our nose. So if molecules are going into the air, they're leaving the piece of paper, and that may change the color.
I'm gonna go try to find a secret one. There, I'm not gonna tell them.
That's what I was
let
going to
them-
suggest. That's what I was going to suggest. If you had any other liquids in your classroom, hand sanitizer, you might have hand lotion. I don't know what other liquids you might have around. Another reason that we're concerned about pH at DEI is that we have a lot of big tanks, small aquariums, our touch tank, huge tanks and small tanks where we grow tiny clams, oysters, scallops, mussels, and even the ocean that I'm looking at out my window. Ocean creatures really like for the pH to be between 8.2 and 8.4, which we would say is slightly basic. They don't like pH to go into the acid range. As I said earlier, for the shellfish, it actually weakens their shell because the acid in the water has a chemical reaction with the calcium carbonate, which is what makes their shells strong. Calcium carbonate is the same mineral, the same substance that makes our bones strong. That's why, one of the reasons we drink milk and eat dairy products, they have calcium in them that helps keep our bones strong. If you have an aquarium at home or the aquariums that we have at DEI, just the waste material, we would say the poop from the animals in that tank, and food that they don't eat, if we fed them too much, that can cause pH changes. So we keep checking those. There are little meters that look something like a thermometer, maybe digital thermometer, that you can put in to help test. There are also liquid chemical tests you can do where you take a sample out and test it. So this pH paper is just one way. There's also something called litmus paper, which just turns pink or blue, depending if something is an acid or a base. Do we have our mystery substance, Mrs. Crowley?
I do.
So we're going to leave that first box blank for right now, because we don't know what it is. Or you can write, I guess you could write mystery, but maybe at some point, Mrs. Crowley, when we get done, Mrs. Crowley will tell us what it is, and you can write that in. But again, she's going to, when she brings a sample around, you're going to dip your paper, your dry, clean, new piece of paper, match it up quickly, write down the color, the number, and whether it's an acid, a base, or a neutral.
So what numbers did we get for this one? 9, 10,
I couldn't decide 9 or 10, so I just went with 9.
So I've got some 9s and some 10s.
Okay, so is this mystery substance an acid or a base, or is it neutral?
What is it, Kinley?
A base.
A base.
It's a base. And what is it, Mrs. Crowley?
It's COVID cleaner.
Wow!
Miss Crystal sprays on all the things around the school to clean it.
Yeah. Notice it's another cleaner. We wouldn't ordinarily make too many assumptions, but we certainly could make a hypothesis. If we did another cleaner, like shampoo or soap, how do you think those would come out? Did somebody say Mrs. Crowley was going to get shampoo?
Yeah.
Now, Mrs. Crowley, I'm curious about the shampoo, because sometimes something happens with shampoos and soaps, things that we're going to put on our own skin. Sometimes sometimes things are added to them to make them look pretty, to make them smell pretty, and also to make them so they don't irritate our skin. So the basic whatever is in this that makes it a shampoo, that makes it a cleaner, would certainly make it a base. But it is possible that it might not test that way because of other things that have been added. So that'll be interesting to see. So has everybody written down the COVID cleaner in its correct spot? And now you can write shampoo.
So what I want you to do is that on the back of your paper, I want you to predict what number you think the shampoo will be. It's a cleaner like all the other ones. Okay, tell me your predictions. Coben, what did you predict? What? 8? 2? You thought it's gonna be more of an acid? Okay. Lily, what did you say? 3. Emma? 9? Colin? 12. Kinley? 11. 7. You think it's gonna be neutral? Okay. 8. 1. Anna? 6. We've got it all over the place.
All right. The neat thing about a prediction, which is like a hypothesis, there's no such thing as an incorrect one because it is a guess. Okay, it's like an opinion. Okay, at this point, we don't know because we haven't tested it yet. I heard someone say it smells good. So that means there's something in it besides just what it would need for cleaning. Some people are really allergic to aromatics, things that smell good. So you might know somebody who has to buy what they sometimes they're called free, like free shampoo or free laundry detergent or free soap that doesn't have all that stuff added. So it would still work the same as any other soap or shampoo, but it wouldn't have those smells that sometimes make us sneeze. And some people, actually makes it so they can't breathe, those perfumey smells. But those also can sometimes affect the pH.
You guys writing down your numbers and your colors? What did you get, Taya?
7.
Taya got 7. Michael?
7.
7. 7.
7.
7. Emma? 8. Kinley? 7. 8. 7.
My prediction was right.
Your prediction was right. Good job.
I heard a lot of 7s and a couple of 8s. So is this shampoo acid, base, or neutral?
Neutral.
It's neutral. A lot of us predicted it would be a base, which generally soaps and cleaners are basic. However, like I mentioned, lots of times if it's a substance that we're going to put on our skin, I mean, you wouldn't generally put an acid on your skin, something that's called an acid. That word acid just doesn't sound like something you'd put on your skin, although not all acids are really that harmful or corrosive or would hurt us. Wouldn't hurt you if you've got a drop of vinegar on your skin, even though it's an acid. Well, the same way that some acids are harmful to our skin, some bases are also harmful to our skin. And so substances are added to those bases like shampoos and soap and sometimes even laundry detergent, so they won't hurt our skin, to make them more neutral. So they still have the cleaning properties, but they don't have the chemical, all overall, with the mixture of things they're made of, they don't have that chemical makeup that makes them a strong base. So I'm not surprised that shampoo came out neutral. Even things like deodorant, sometimes even on TV ads, when they're advertising a deodorant, they'll say it's pH balanced. That's what they're talking about. That means even though something like that would normally be a base, substances have been added to make that neutral, so that when you spray it on you or rub it on your skin, it's not going to hurt your skin, not going to irritate. We've ordered some liquid test kits to use with kids when they get back to DEI, to test the ocean water in the lobster ponds and in the big pond up across the road. And we'll be testing pH in a little bit different way.